Welcome to this channel. In this video, we will find the solution of Riccati equation by power series solution method. Riccati equation is dy over dx plus q of x y plus r of x y square is equal to p of x. Let q of x is equal to 0, r of x is equal to a, and p of x is equal to b x raised to power n. Then equation 1 become dy over dx plus a y square is equal to b x raised to power n. This is equation number 2. Now we will use transformation. Y is equal to 1 over a u of x du over dx. So dy over dx is equal to minus 1 over a u square du over dx whole square plus 1 over a u d square u over dx square. So equation 2 become minus 1 over a u square du over dx whole square plus 1 over a u d square u over dx square plus a multiply by 1 over a u du over dx whole square is equal to b x raised to power n. So this term and this term is cancelled out, so this become 1 over a u d square u over dx square is equal to b x raised to power n. This is equation number 3. Multiply by a u, so this become d square u over dx square is equal to a b x raised to power n u. Let a b is equal to c square. Then this become d square u over dx square is equal to c square x raised to power n u. This can also be written as d square u over dx square minus c square x raised to power n u is equal to 0. This is equation number 4. Use transformation. U of x is equal to v of x exponent a x raised to power p, where v and exponent both are the function of x. So we du over dx is equal to, now we'll apply product rule. So this become derivative of v of x exponent a x raised to power p plus v of x exponent a x raised to power p a p x raised to power p minus 1, and d square u over dx square is equal to double derivative of v of x exponent a x raised to power p plus derivative of v of x exponent a x raised to power p a p x raised to power p minus 1 plus derivative of v of x exponent a x raised to power p multiplied by a p x raised to power p minus 1 plus v of x exponent a x raised to power p a p x raised to power p minus 1 multiplied by a p x raised to power p minus 1 plus v of x exponent a x raised to power p a p multiplied by p minus 1 x raised to power p minus 2. So d square u over dx square is equal to d square v over dx square exponent a x raised to power p plus 2 dv over dx a p x raised to power p minus 1 exponent a x raised to power p plus a p multiplied by p minus 1 x raised to power p minus 2 v of x exponent a x raised to power p plus a square p square x raised to power 2p minus 2 v of x exponent a x raised to power p. So equation 4 become now we will put the value of d square u over dx square and u. So this become, and at the same time we take common exponent a x raised to power p. So remaining become d square v over dx square plus 2 ap x raised to power p minus 1 dv over dx plus ap multiplied by p minus 1 x raised to power p minus 2 v of x plus p square a square x raised to power 2p minus 2 v of x minus c square x raised to power n v of x is equal to 0. This can also be written as d square v over dx square plus 2ap x raised to power p minus 1 dv over dx plus ap multiplied by p minus 1 x raised to power p minus 2 plus p square a square x raised to power 2p minus 2 minus c square x raised to power n multiplied by v of x is equal to 0. Now we consider 2p minus 2 is equal to n and p is equal to n over 2 plus 1. So p square a square is equal to c square and a is equal to plus minus c over p. So these last two terms is equal to 0. So this become d square v over dx square plus 2ap x raised to power p minus 1 dv over dx plus ap multiplied by p minus 1 x raised to power p minus 2 v of x is equal to 0. This is equation number 5. Now put A is equal to C over P in equation 5. Then equation 5 become d square V over dx square plus 2c x raised to power p minus 1 dv over dx plus c multiplied by p minus 1 x raised to power p minus 2 v of x is equal to 0. This is equation number 6. Multiply x square. So this become x square d square v over dx square plus 2c x raised to power p plus 1 dv over dx plus c multiplied by p minus 1 x raised to power p v of x is equal to 0. This is equation number 7. Equation 7 is Cauchy-Euler equation. Now use transformation or power solution v of x is equal to summation m is equal to 0 to infinity am x raised to power pm. This is the solution of Cauchy-Euler equation. So derivative of v of x is equal to summation m is equal to 0 to infinity pm am x raised to power pm minus 1, and second derivative of v of x is equal to summation m is equal to 0 to infinity pm multiplied by pm minus 1 am x raised to power pm minus 2. So put the second derivative, first derivative and value of v of x in equation 7. So this become summation m is equal to 0 to infinity pm multiplied by pm minus 1 am x raised to power pm plus summation m is equal to 0 to infinity 2c pm am x raised to power p plus pm plus summation m is equal to 0 to infinity c multiplied by p minus 1 am x raised to power p plus pm is equal to 0. This is equation number 8. Compare coefficient of x raised to power p plus pm. To make this term p x raised to power p plus pm, we place m by m plus 1. So this become p multiplied by m plus 1 multiplied by p multiplied by m plus 1 minus 1 a m plus 1 plus 2c pm am plus c multiplied by p minus 1 am is equal to 0. So this become m plus 1 multiplied by p multiplied by pm plus p minus 1 a m plus 1 plus 2c pm plus c p minus c multiplied by am is equal to 0, and am plus 1 is equal to minus, we take c common, so this become 2pm plus p minus 1 am over m plus 1 multiplied by p multiplied by pm plus p minus 1, and m has value from 0, 1 to so on. If m is equal to 0, then a1 is equal to minus c multiplied by p minus 1 over p multiplied by p minus 1. A naught, let a naught is equal to 1, so this become minus c over p. If m is equal to 1, then a2 is equal to minus c multiplied by 2p plus p minus 1 a1 over 2p multiplied by p plus p minus 1 is equal to minus c multiplied by 3p minus 1 over 2p multiplied by 2p minus 1, and a1 is equal to minus c over p. So this become c square multiplied by 3p minus 1 over 2p square 2p minus 1. And we have considered v of x is equal to summation m is equal to 0 to infinity am x raised to power pm. If we open the summation, so this become a naught plus a1 x raised to power p plus a2 x raised to power 2p plus so on. A naught is equal to 1 plus a1 is equal to minus c over p x raised to power p plus, and a2 is c square multiplied by 3p minus 1 over 2p square multiplied by 2p minus 1 x raised to power 2p plus so on. And we have considered u of x is equal to v of x exponent a x raised to power p. So this become, and use the value of a, which is a is equal to c over p. So this become u of x is equal to exponent c x raised to power p over p multiplied by 1 minus c over p x raised to power p plus c square multiplied by 3p minus 1 over 2p square multiplied by 2p minus 1 x raised to power 2p plus so on. If c is equal to minus c, then equation d square u over d x square minus c square x raised to power n u of x is equal to 0 remain unchanged. So if we solve this equation, so the solution of this equation is again u of x is equal to v of x exponent a x raised to power p, and now we'll use a is equal to minus c over p. So this become exponent minus c x raised to power p over p, and v is 1 minus c over p x raised to power p plus c square multiplied by 3p minus 1 over 2p square multiplied by 2p minus 1 x raised to power 2p plus so on. We call this u of 2 and this is u of 1, and we have considered y is equal to 1 over a u du over dx, and u is equal to u1 plus u2.